1.5 million to 18 and then more recently, before going to sleep, hold their great grandchildren. Great. Perfect.
Okay, everyone, thank you for coming. We're going to get started here. Thanks for joining us in the afternoon for the crash course. We're going to have a discussion about Passive House, and the speakers are Ken and Marty. And Kristen's going to introduce both of them and give you a background.
Hi, everyone. My name is Kristen Bell, and I'm one of the co-chairs along with Pablo Rodriguez of LEAP. And so we're really excited today because we have Ken Levinson, who is actually a Pratt alum, which is very exciting. And he's a registered architect who's the president of a nonprofit New York Passive House, and also the COO of 475 High Performance Building Supply. We also have with us today Marty Rowland, who is a professor at Pace, teaching environmental sciences, as well as the, okay, I have to check, I can't remember. He's a certified Passive House designer, and he also works for New York City Department of Parks and Recreation. So thanks so much for joining us, and take it away. Thank you both.
Okay. Thank you. Thanks a lot. I appreciate the opportunity to speak today. I think you'll be pleased with what you're going to be hearing. We've got myself and Ken been in the Passive House movement, let's say, for several years now. What I want to do also is explain that I'm not here representing the Parks Department, just where I work. At the Parks Department, I'm an environmental engineer. I manage contaminated soils, get permits, make sure that we are compliant and such like that. But my PhD is in urban studies. I studied under an economist named Daniel Bromley, who was a colleague of a woman named Elinor Ostrom, who got the Nobel Prize in Economics in 2010 on governing the commons. She wrote a book, and that's really for another talk. But today I'm going to be talking about passive houses and some ideas that came out of the training manual for the course that you could take and become a certified passive house designer. Okay. Oops. First thing I want to do is identify the things that maybe we should avoid happening. I think that one idea behind passive houses is building the type of houses that can withstand expected impacts. Can anybody tell me some of the highest costs involved in the Sandy recovery, and why maybe some of it shouldn't be a cost, considering the fact that a lot of these houses were near the ocean and high winds, high waves?
With furnaces should be in the attic.
Yeah. So you can see all these things like drywall, furnaces, all these things that wouldn't be damaged if you had passive houses. You know, if you're living near the ocean and you expect water to be coming in, maybe concrete would be a better design. So when we spend all this money replacing, we're just replacing what was damaged. So the next hurricane, we're going to have the same slide, probably even more. So, but I'm thinking that in terms of passive houses, a lot of the concepts are, what is your specific locational characteristics, and design the passive house around that. One of the things that Ken and I are going to be talking about is the opportunity to save at least 75% on the heating consumption as compared to standard housing. And I'll show a little bit of the reason behind that, the energy savings, which is primarily in the insulative values of the envelope and the air tightness of the building. So this is an important slide in terms of the understanding what is involved in getting a certified passive house. We're not taking into account the losses from the extraction, conversion, transport. That's just to illustrate where the energy is coming from. But the primary energy coming into the building boundary are the electricity, might be the natural gas and the fuel oil, that whatever you have. But you have certain gains, and this is one of the issues behind the passive house concept, that you're for northern climates, and maybe I should clarify right at the start that the passive house standard originated in Europe. So there's a lot of in Germany and those countries where you have cold winters, and that's why a lot of the factors involved in the passive house system involved capturing solar, so that solar gain. There should have been QS coming in if you're going to identify all the various Q factors on here. This is the heat that's coming in that's not lost, transmission losses, ventilation losses, and also an important factor is the internal gains. Just the fact that you have a light bulb on, a refrigerator, stereo, hair dryer, people are all factors of energy that you can capture within here so that you don't need, say, a large furnace for your energy gain. One of the ways that passive houses, well, actually, the way of achieving the 75% saving is to have this heat exchanger, energy recovery ventilation, where the air coming in is conditioned by the air going out so that you achieve 75% heat recovery. You can see this is a winter scenario where you have the low angle of the sun coming in and heating up the interior. But one of the things to look on here is the connectivity or the connectedness of this insulating envelope in yellow here, and the green here is the airtightness barrier. And a lot of the busy work, I'm going to get into what those numbers mean, but one of the ideas behind the principle of cross ventilation, for example, would be bringing in the indoor air that's been conditioned to the living spaces. You might go into a corridor. Then you extract the air to the outside where you have things that you would expect, perhaps odors or other kind of bathrooms, kitchen, maybe utility room, places where you drop off your smelly shoes, laundry, that kind of thing. And this is the 6 factors for getting a passive house certified. You'll see this number when Ken talks with the 4.75 kilo BTUs per square foot year for the energy heating demand and the cooling demand. You'll see this number in a few slides here. This is the heating load, and I'll explain a little bit difference between the demand and load in a second. But 3.17 BTU per hour square foot. This is sizing the heating system, whether it's a heat pump or other device for bringing in the energy. And this is typically about 10% of what a normal building would have. So you can see right off the bat that there's a lot of expected energy loss in a standard built house. And then this primary energy demand, 38 kilo BTUs per square foot year. This is the energy coming in. So if you've got electricity coming in, fuel oil, natural gas, all these things, you look at what the demand is here and what you're using for heating and cooling, ends up, the heating and cooling is like 12.5% of this total. So if you are sitting in a yoga position and not turning on your stereo, or you don't have a lot of electronic devices, this number will probably be a lot lower. But in a normal household, you're going to have, games, TV, and loud music and things like that. So you can have that in a passive house. Heating demand, this is the accumulated amount of energy required to heat a room of a building for a defined period of time. It's in kilo BTUs, and then the load is, like I said, it's like sizing the heating system. Could be the cooling system as well, but it's power, so it's two different concepts. One thing I didn't mention on the in this certification criteria is the building airtightness, and this is the level that you have to achieve air changes per hour at 50 pascals. You put a blower, a fan making a negative pressure, and you can achieve that air changes, then you achieve the standard. And there's also some accommodation for excess temperature, but the ideal is 68 degrees Fahrenheit. There's a little accommodation in the summer where you can have some excessive temperatures because of the heat being involved. This is the design for a compact heat pump, and you can see a lot of different factors. There's things going on all over here where you have a subsoil heating where air is going through a system that's below ground, where like in the New York area, the temperature 3 to 6 feet below ground is at a constant 52 degrees Fahrenheit. You can condition outdoor air coming in. You got heat exchanger. You could have a solar water heater. Could be a way of heating up your water here, but because of the low heat demand, or because of the low heating load, you can often do everything that you need done with a heat pump as opposed to a furnace or air conditioning. One of the ways that you size the heat pump, for example, or whatever system you have for the heating load, is to pick the extreme conditions. Typically with a passive house, you look at the moderate cloudy day as what you model it to get the be most conservative. And so you don't want to size something that's not the most extreme. And the idea behind this is even though it's cold and clear, you're getting the radiant energy, but because the envelope is so well insulated, it's this condition that you might have to use more heat because you're not getting the solar energy. And that's why that works out that way. There was an example in the training manual I borrowed here that shows the influence of the south-facing windows and what square footage was necessary to not too much, not too little. I think it turned out to be 30% of the south-facing wall was this area here, and if you had one big window, it'd be 16 by 16, but the 269 square feet. You can see the 3.16 is the heating load that you can't exceed if you have a passive house. And it was right at this intersection of the second condition, which is the moderate cloudy day, and this is the cold and sunny, and the intersection right there. And that's how you come up with a design for how big the window should be and the percentage of the wall. This is an interesting way of conditioning and capturing the heat from subsurface, was having a system that's filled with brine that's capturing that constant 52 degree Fahrenheit temperature that you can condition to indoor air. So there's a lot of different ways of reducing the energy that you need to create. Various parameters. I wanted to just to highlight the no thermal bridges factor in passive houses, because this is where you get the low energy usage. I've got an example that's right after this. Average air change rate per person, got minimum air change rate, occupancy rate, a lot of these different things that you plan on. But this is a diagram showing the issue behind thermal bridge free design, where you might have some cantilever balconies where you got a lot of heat loss through here. And what you try to do is break up the this insulated barrier and create a separation. So even though it's still there, you can, for example, have the structure on the outside of the wall. You have some shading going on there, and you have the balcony there, so that it's kind of like don't violate the envelope insulative layer, because that's what's getting you the features that you need. Some more design features of the passive house, just for examples of hot water, domestic hot water design, 6.6 gallons per minute or gallons per person. Some additional factors. Now this is getting to be pretty large. I guess in some very cold climates, having R value in excess of 70 is, you're getting, if you had batting or wool of some sort, extruded polystyrene, with about 10 inches, you can achieve the 37. But you can see an example of the R value. And one of the things interesting is the windows. Even though that the windows are giving you this much lower than the 37, which is the standard, you're getting the solar gain, but it's not so much that you're losing it once it's gained. So this is the triple pane window, which is standard for passive houses. And this gives you an example comparing the standard building stock and passive houses. You can see where the triple pane glass is allowing you to maintain the comfort level at average around 69, 70 degrees. Here's the heat pump, heat changing. And as opposed to the standard house where you have a radiator near the window, and the reason the radiator is near the window is that that's where you're getting a lot of the losses. So there's a lot of variation in the interior temperatures. This is a diagram showing in summer you might want to open some windows. You got the solar coming at a higher angle. And it's an alternative way of running your passive house. And my last slide before I tell a little story, this is an example of what is the configuration that's optimal for a passive house. Looks like anything greater than 2 stories is the ideal. Once you get down to single story, it's kind of hard to have an optimum area volume ratio. So as you go from 0.7 on this way, it's a lot easier to attain the optimum ratio. I wanted to leave with a fable that I wrote to illustrate the point about passive houses. And the point that I think is there's political and economic issues involved in why aren't all passive houses, or why isn't passive houses the standard? Why is it the exception? And if you just think about the natural gas industry, for example, where we've got houses that leak energy And because natural gas has been cheap, we just burn it and waste it. So I wrote this fable just to illustrate what I think is maybe some of the problems and provide some opportunity for people to reflect when we get into question and answers. Let me see where I'm at on the time here. Okay. So the fable is called The Fable About Pants with Pocket Holes. Once upon a time, all money was in coin, and all people wore pants. The first pair was sewn by a person who ran out of thread when sewing the bottom of pockets. Anybody wishing to change this hallowed design was ostracized, and tradition carried on, pants with holes in pockets. Naturally, people expected to lose their coins with holes in their pockets. Then a savvy entrepreneur got the city to install steel grates on every sidewalk that allowed dropped coins to be collected out of reach of people with holes in their pockets. Eventually, those in the political class captured the steel grating franchise, and a new status quo was born. All was well until one day an immigrant tailor who had been shut off from modern civilization suddenly appeared wearing pants with no holes in the pockets. After witnessing the injustice of wealth loss through coin loss, the immigrant opened a shop specializing in sewing the bottom of pants pockets. Immediately, the arrested immigrant was deported, charged with creating public disorder and theft. Theft? Yes. The steel grating conservancy began losing their money flow, but slowly the innovation caught on, and a new social order was emerged. So that was an example of there's just slow to catch on for new ideas. We do it because we've always done it this way, and I think that's what we're trying to come up with today, is to look at, challenge the assumptions of why our housing stock is the way it is, and I think it's a challenge for all of us to say, well, what can we do to have good designs and make this a more common way of construction. So I'm going to turn the talk now over to Ken, and we'll take questions when Ken's done with his portion. Ken?
Great. Thank you, Marty. All right, so we'll see if we can, I don't know, Mac. Just hit escape. So that's not messing up the.
In the very back.
Whoa.
Wow, look at that.
Okay.
So I can forward it. It's cool.
Okay.
No, hold on.
It's all set.
Oh, it's all set. Sorry. Good. All right. Thank you for having me. Thank you for inviting me to be here. So Ken Levinson, I'm a graduate of Pratt Architecture undergraduate, 1989. It's been a few years. I do get back here, not as often as I would like. I just live in Park Slope, but it's great to always come back and very much like participating in events like this. After graduating in '89, I worked at a number of small architecture firms, design-oriented firms in the city, and eventually went out on my own and had my own small firm for, gosh, I don't know, it was probably about a decade. And worked on a variety of projects, and what happened was, I think it was about 2008, I started to become increasingly obsessed with climate change. And I was looking around on the internet and putting together some information for the Park Slope Civic Council for an event, and sort of stumbled upon Passive House on the internet. And it was kind of like this aha moment where you have this whole methodology and approach to building that is speaking to sort of the fundamental performance of the building and speaking about it in a way that actually addresses climate change proportional to the challenge that we're facing. Everybody talks about reducing carbon by 80% by 2050, but everybody's having a really hard time describing how we actually get there. Even if you incorporate Passive House, it's going to be quite a journey to get there, but Passive House is actually talking about numbers that hit it. It's not a 10% improvement, it's not a 20% improvement. We're talking about reducing cooling and heating energy by up to 90%, overall energy by about 75%. So it's really nice to get to find something that gets you in the ballpark, so to speak. And is really, I would sort of throw out the pitch that in terms of renewables and going to nearly zero energy buildings, it really has been so far the most cost-effective way to get there. You push down your demand as low as possible, and then it's really easy to add solar panels to your roof and be net zero because your demand is so low to begin with. So really addressing the demand side first and foremost as the top priority is really one of the key nice things about Passive House. So, you know, it took, there were hardly any classes at the time. I had to go up to Boston to take a consultant's class. Today, there are regular classes in New York City, not just for consultants, designers, but for tradespersons and for a lot of the specialized aspects that we'll get into around Passive House. So there's a lot of resources available. And one of the things that today, and growing rapidly, and so we formed, there were a small group of us, we formed New York Passive House in 2010 as a grassroots organization to help promote Passive House in the region and to share resources, get people talking together and learning from each other's work. So I encourage you all, if you're interested, to find out more about New York Passive House. I'm the president of it, and we have regular events. Just we're also we are part of a national network with other regional groups from California, New Mexico, the Northwest, Maine, and also internationally with the Passive House Institute in Germany, the International Passive House Association. So one of the cool things about Passive House, too, that a lot of people find exciting is that it's truly an international, global approach to construction and dealing with energy. It's a global issue. Construction is a global industry, and this really speaks to that. And so, in particular, with the English-speaking nations, it's been great with Ireland and the UK, New Zealand in particular, sharing resources. So we're doing specialized training, just a quick pitch here for different programs that we're doing on-site, things happening, events going on, and then one event in particular I want to make sure you all know about. June 17th is a Tuesday in New York City at the Metropolitan Pavilion, 6th Avenue and 18th Street. We're going to have a one-day conference, and it's going to feature big buildings. One of the things that you know, Passive House suffers from the name of the translation to house, and everyone thinks of Passive House as residential building, detached houses to start with. And it takes quite a bit of energy, unfortunately, to get people to reframe what Passive House is about. And it's really about all building types, all building sizes. And as Marty alluded to, spoke of the proportion of the buildings before, the bigger the building, it's actually easier to do Passive House. Passive House is really made for big buildings, for multifamily. So we're having a conference that focuses on schools, apartment buildings, office buildings, stores. And we're going to have practitioners from the UK, from Ireland, from Austria, and other places to talk about their work, as well as New York. Right now there is a 20-story tower they're doing a feasibility study to look at Passive House in New York City, as well as a 50-story tower that this feasibility study is being done on for real. So it's not pie in the sky, it's going that direction. And nothing is really off the table in terms of what it can do. So we like to step back and say, you know, the energy is the eye-popping thing, and it's really what brought me to it and a lot of other folks to it, but it's important to understand that Passive House is really about really broad objectives, and a lot of the mechanics and the metrics that Marty was speaking to before go to establishing these kind of qualities. So health was really baked into the standard from the beginning. They wanted these buildings to be as healthy as possible. They wanted them to be the most healthy buildings. And we'll see how we deal with that a little bit. Comfort. They wanted them to be the most comfortable. Basically, they didn't want to give people an excuse not to build a passive house. We have the energy. Affordability. You know, this is probably one of the more quote-unquote controversial aspects of Passive House, that certainly when everyone thinks about it and when you first approach it, you know, you're talking about doing more insulation, more air sealing, you know, more quality control. There's much more demanded on the designer and the construction crew in a way to produce a Passive House, which is going to drive costs. But by the same token, which we'll go into it a bit here, the methodology allows you to optimize systems and realize savings in the construction process. So your mechanical systems are can be 75% smaller than what they typically would be, for example. And what we've seen is after the first job, which is really oftentimes for the team, the first job is a steep learning curve. But after that, and you have a sense of what needs to be done and you're planning forward from day one, the costs go down, the additional cost goes down towards parity. In Europe, they are basically between 5% above standard construction down to no added cost. In the US, if it's the first project, you could be looking at 10 to 15% upcharge on the construction costs to do Passive House, and a lot of that is really baked into just doing it for the first time. And what we're seeing is the costs going down, where many costs are, you know, in the 5% added range. So much more manageable. One thing that's changed is that in terms of the affordability, as more people are doing it, it's less exotic. People are willing to do it, but there's more products available, more windows available. Windows are probably the biggest single driver of the upcharge at the beginning. 6 years ago, there were 2 window manufacturers importing from Europe. Today, there are over a dozen. So there's a lot more competition, a lot more available out there. Oh, I should say, I think I sort of cut off my introductory talk saying that. So I was doing architecture. I got hooked on Passive House, and so I decided that you know, all my projects now have to be Passive House or low energy buildings, at least using the methodology that we'll talk about. And I was very lucky and fortunate to have some clients who were willing to go along for the ride. What we realized in working on some of these initial projects, which we'll take a look at some slides from, was that we were having a real problem finding some of the materials, and the building supply industry really wasn't all that interested in supplying the materials because it's such a sliver of the construction industry at this point. They see no reason to invest in it at all. So we saw a real opening in the market there for this service, for these products. So we started 475 High Performance Building Supply, which is basically an e-commerce online, and we import specialized products from essentially from Germany and distribute them across the U.S. And we work with architects, consultants, developers, owners, in figuring stuff out. And so consequently, to start the business, I stopped taking architecture jobs and have kind of mothballed my architecture practice for the time being, and the hope is after building a successful company, if it doesn't kill me first, come back to architecture one day. But for the time being, see if we can't make this business fly.
What's the name of it?
475 High Performance Building Supply. That's the number 475. So that comes from the Passive House standard, 4.75 kilobTUs per square foot per year heat demand. So back to affordability. So there's more people and people like us getting into it, making products available, bringing down the costs, sharing the knowledge, and making it more affordable. So the affordability with the upcharge, a rule of thumb, what we've seen in a lot of projects is that the simple straight payback on it, so on the added upcharge from the energy savings that you get is about 8 years. But typically the way the calculations are working, especially with interest rates the way they are, the additional money that you need to borrow and the cost of that additional money to do the upgrade to Passive House is going to be less, and substantially less, if not a big number, but definitely less than the amount. Or I should say, it's going to be more than the amount that you're going to save in the energy from Passive House. So really, does that make sense? So for day one, you're saving enough on your Con Ed and your utility bills that you more than can pay for the extra money on the mortgage for the money that's borrowed. So it's really profitable. It's really making money on day one. You're really not losing anything. You do have to leverage a little bit more, but the finances work out from the beginning. And then, because of the dramatic utility savings, if you're on the building owner side and it's paying for itself is great, but also in terms of, owners of multiple family rental buildings, huge incentive, or commercial buildings, there's big money going into the utilities. But if you're, just a regular person in affordable housing, regular housing paying your own utility bill, it makes the housing much more affordable if your power is reduced by 75%. A huge cost reduced. Predictability is another core aspect of it. One of the big things with sustainability in general and sort of the promise of green design, and particularly dealing with performance. We want more comfortable buildings, more healthy buildings, we want people to be happy in them, and we want them to save energy. A lot of the performance of the buildings as actually monitored are kind of all over the place. And there's been a lot of pushback in terms of how much money we're spending into the buildings and what are we really getting for the return. And with Passive House methodology, it sort of really locks it down and makes it much more predictable. So you have a much higher level of confidence that you're going to hit the numbers that you say you're going to. And you really need to, because if you're reducing your heating and cooling system by 75% in the construction, your demand really has to be dropped, right? Then you're going to have some very unhappy occupants and building owners if it's not working. So, and we'll talk about what goes into that predictability, but it's really fundamental. And then resilience, which is, an ever more important topic. And one of the fundamental interesting things is this idea of sheltering in place, and particularly in a cold climate without heat. And post-Sandy, it was one of the key recommendations to study further this idea. It's still a ways out in terms of building code, but this idea that we should really think about building our buildings in a way that if we have a blackout in January, in the wintertime, that people don't need to be evacuated, that they could actually shelter in place. And what it describes actually is a Passive House, that quality, because a Passive House in January, if you were to lose the heat indefinitely, basically, it will find an equilibrium between the passive solar heat gains, the internal heat gains of the people, and saving preventing the heat losses of about 55 degrees. So not the most comfortable environment, but it's a place where families could stay. everyone wouldn't need to flee. So this sort of is all possible and has picked up steam at the Passive House Institute, which is in Darmstadt, Germany, which was founded in the early 90s. And they developed sort of a set of metrics and tools to use to help realize the methodology. You don't have to use any of this. You can do a passive house with whatever components you want, however you want to do it. You know, to hit, as long as you could collect the data to show that you're hitting the performance targets of what describes a passive house with a 4.75 kBTUs and so on, you have a functional passive house. But what they've done is really develop tools to make it a lot easier and a lot more predictable. So from the methodology, the PHPP is the energy model, which is really important. Training professionals, not only consultants, but tradespeople. And architects and designers like to take the tradesperson course too, because it's shorter, it's more hands-on, and a nice balance between the conceptual and hands-on training. Both of these are produced by Passive House Academy with the Association for Energy Affordability in New York City. And then we have certification and components. There are some key components like the windows, the ventilation system, some thermal bridge-free connections that are really required. Again, not absolutely required functionally speaking, but in terms of making it realistic to hit it, you need to use it. So with all of this, and we'll circle back around in other ways, the predictability is kind of astonishing. So this is a house in Park Slope that was done. Kramer Silkworth was the engineer and the Passive House consultant. I should say Red Top Architects were the architects on the project. And so this last winter with the polar vortex happening, this is a week in time in January, early January. And the data collected in that week in time, we showed the temperature at one point going down to 5 degrees at nighttime. Pretty chilly the whole time. Over the whole week, the only time that the heat was turned on inside the house is right there, that vertical line. So that's from actual collected data, which, you know, even Kramer, who designed it, was shocked when he saw it. And so there was a nice little article in JLC magazine, Journal of Light Construction, on a few different passive houses and how well they performed through the polar vortex this winter, which was exciting to see. So again, you know, it's all pretty new in a way. 1990 is the first passive house. It's 4 flats in Darmstadt, Germany. But in another way, it's all old. The neat thing about passive house is kind of, it's not reinventing the wheel. It's not really new technology. It's been there. What they did was they just sort of much more rigorously integrated it. You know, insulation, yeah, there's an evolution in components and in the windows, in the insulation and air sealing products, but it's not a revolution. It's not really a new way of thinking about things. It's just thinking it through really thoroughly and thinking it through on day one and really incorporating it. A lot of folks have problems, and it's one of the main cost drivers that we see in first projects, is that people find passive house to get really excited about it. They have a project on the boards, and they say, which is already basically designed, and they say, oh, this has got to be passive house. We can't build this, you know, not passive house anymore. But at that point, the building wasn't designed to be a passive house. And while a passive house can be any type of building, it's really shoehorning the methodology in if you've already got a building and you're trying to make it work. I mean, it's theoretically possible and easy in some cases, but a lot of times it's going to be, you end up seeing like ridiculous sort of things that need to be done to be certified. But if you start in day one and go through, pretty straightforward. pretty easy. I mean, you need to make decisions, design decisions like you do with any programmatic sort of list that you have that play into it, but a lot more is possible. So 1990, and then basically until 2000, not a lot was going on. But then after 2000, it really started to explode, particularly in the EU, based on EU studies that were done and funding to sort of make it, to verify that this is doing what it says it does. And today, really around the globe, from Vienna to Beijing to Seoul, South Korea, it's exploding, really, internationally. And leader today is really Brussels, Belgium, not even in Germany or Austria, where next year, in 2015, Passive House is going to actually be the building code, which seems kind of unbelievable. This is all new buildings and all substantial retrofits for both public buildings and private buildings. And they're managed to go from literally 0 passive houses just a few years ago, and through a series of well-planned rounds of competitions and training, they've been able to move industry to a degree where when the politicians went to push this through, where you would figure you would have huge pushback from the construction industry and the real estate industry, they didn't blink. They really, not substantial pushback at all. So it's happening, again, all kinds of buildings and everything. So it's really fantastic. You know, in terms of training and some resources, and certainly please speak to me after if you'd like and going forward. But PassiveHouse.com is the Institute's website in Germany. And Passive House Academy is the primary educator in the US for Passive House consultancy. There are others coming online, and we're encouraging it to develop more accredited organizations. But the Academy has really been at the forefront and been doing an amazing job. And then New York Passive House, of course, our local group, which is helping tie it together. The Related Organizations Association for Energy Affordability, which works with the Passive House Academy, they've been doing a great job. The International Passive House Association is part of the Passive House Institute. And then I'll put our own company in there, just as a pivot point. We're really having a lot of fun in talking with people from all across the country and getting people together and planning, you know, this conference in New York. We're planning one in Portland, Maine for September, a continental-wide conference. So just a lot of exciting. And we do a lot of building science related stuff on our 475 website that's sort of around Passive House concept. So the first project that we were fortunate enough to be able to do the Passive House standard to was a retrofit of an 1847 townhouse in Brooklyn Heights. And you know, one thing about retrofits, and the thing, you use the Passive House methodology for any construction that you're using, which we'll talk about more in a second. But to the extent that it's realistic to actually hit the certification metrics, it can be quite difficult and onerous. And unless you're doing a renovation where you're gutting the building, it's going to be nearly impossible to hit that kind of energy savings. So for retrofits, renovations, we're talking about essentially gut renovations. You may be able to salvage parts of the inside and redo it, but the shell, you need to get to every part of the shell of the building all the way around. But it's doable, and you can have, you know, this is sort of, we put back some of the historic detail, and there's a bit of modern eclectic depending on where you are in the house. But passive house doesn't have to look modern, doesn't have to look historical. It can look however you want the designs to look. It's not mandating any particular approach to the work. But it is regarding the guts of the building. So first and foremost, as Maury was talking about before, is really optimizing the thermal enclosure. And this is sort of where the main hurdle, not the only, but the big one. Because to think about conceptually passive house is you're really, and where the name comes from, is you're really trying to optimize those things that you have to do anyway, the parts of the building that need to exist essentially even when the lights aren't on. So you have to have insulation in the building. You're going to do it. You're going to have windows. You need to have airtightness. Now, some people would argue you don't need airtightness or you don't want it, but as we go into building science fundamentals, airtightness is really second to keeping the rain out. We all agree you need to keep the rain out of the building. Airtightness is the second most important aspect of a well-performed building. It's even more important than insulation. If you had money to spend on upgrading a building and the choice was between installing insulation or airtightness, spend the money on airtightness. It's a huge impact in terms of the efficiency and the comfort and the indoor air quality, and the longevity of the construction, the quality of the construction. And it's one of the reasons why airtightness is really the only physical metric that's required to be verified by the passive house standard. All the other stuff with the passive house that Marty was showing with the numbers, that's all in a spreadsheet. It's all in the design. It's all in the calculation. You need to build the building per the spreadsheet. You need to show details and photographs, and it needs to be built. But the one physical thing you're testing is the airtightness of the building. That's absolutely essential, and it's super airtight. So continuous insulation. And people get continuous when you're talking about walls, they get continuous when you're talking about roofs. But where it gets tricky is the corners, where the wall hits the roof, meets the roof, where it meets the floor. You need continuous insulation on the floor. So in this house, where we may not have insulated the cellar at all typically, here we dug down, we had R20 insulation on the ground, and then put a slab, an air barrier and a slab over that, and made sure that the insulation was continuous with the wall, up, around, all the way. The windows need to be fully integrated as part of the insulation and the airtightness. And those connections can't be thermal bridges. So the thermal bridge is where you have a sort of an anomaly of thermal transfer. You can imagine a nice insulated wall has a certain resistance to thermal heat loss, but then like the metal window frame, you have much less resistance and much more heat going through it. And so that differential, where you have a great differential, is thermal bridge. You want to have a very consistent, thermally consistent envelope so that the temperatures, the interior surface temperatures of those exterior assemblies are very near the room temperature. So this wall, those windows, are practically at room temperature. So that means you don't have to have the heating below the windows. You don't have to have air conditioning above it. You can pull all those systems into the building and really simplify things. So concentrating on these three things, absolutely critical. And the windows, you can't have double hung windows in a passive house. That's the bottom line. Tilt and turn, fixed, casement, things like that, but double hung windows essentially leak too much. Even the good ones, they'll leak. You basically have to nail them shut, tape them shut, and walk away from them. So over a series of projects, we were actually able, with some other architects, working with the Landmarks Preservation Commission, able to develop some early simulated double hung windows. Thank you. So what you have is a fixed window. This pane doesn't move at all, and the bottom is a tilt-turn window. So it opens like this. One way, this is the tilt, the hopper, and then like the casement and swinging. Now, and they would say if you're working in historic districts and you need to deal with Landmarks Commission and you need to deal with preservation community, and you may be a preservationist yourself, there's certainly no, the two things aren't exclusive, although sometimes it can seem or feel that way when you're trying to innovate and do something new, particularly around insulation, and there are a lot of red flags thrown up. So I would say you really want to embrace the preservation community, talk to them, which we did in this project, and have help be part of the communication that we can improve these buildings and make them high performance for the next 100 years and make them actually better buildings and not sacrifice them. You need to be careful, and it's you need to do it very carefully in partnership with them, but it's totally possible. And I just put a note, as you're looking, if you're looking to do this sort of thing, not only doing the training, thinking about the designing and detailing and stuff, but it's important, to write stuff. We do a lot on our own blog on 475. In this case, I was very happy to put this little article out on the Salon Foundation website on historic preservation and passive house working together, and just to highlight that there's a lot of work to be done. Our city has largely been built. The historic districts are huge, and we need to, as the buildings are renovated, we need to bring them up to the highest level possible. So we all want to just encourage you to engage in that sort of conversation. So the heating and AC, the cool thing is, so while I should note, no matter how much outreach we did ultimately, on the windows were so problematic, we had like 4 different preservation groups testifying against us at the public hearing, screaming that the tilt turn, the simulated double hung windows were the end of civilization as we knew it. And they weren't kidding. It was really quite an experience. And but funnily enough, after the end, once the windows were installed, one of the head of the Brooklyn Heights Association, walking by the building, she lives like 2 blocks away, came by and was like, oh, well, maybe they won't be so bad after all. And the Landmarks Preservation Commission, I should say, has been incredibly supportive. And it wasn't a unanimous approval, but we did get approval, and it's gotten better, and the designs are changing over time and getting better. The thing that's really neat to pitch to the historic districts is that we're reducing the mechanical systems by 75%. So all the neighbors to this house had 12, 15 tons of air conditioning on the roof, and you get an exemption for mechanical systems in the historic district. They can't do anything about it. We calculated for the house where the neighbors had 12 to 15 tons that we needed 1.5 tons of air conditioning, which is 18,000 BTUs is a window unit. I mean, that could be 18,000 BTUs right there, which scared the heck out of us. Because if you're spending, $1.5 million on your home renovation, you'd like to put in a little bit more than that window unit. So we put in 3 tons of air conditioning, which rather than being a monstrous thing on the roof, tucked in very nicely and is out of the way and doesn't cause very much noise. And not only does it do the cooling, but it also does the heating. So we can eliminate the traditional heating system of the hydronic perimeter heating system and all that money. So we have the Yeah, the condenser, the air to air, is it? It's not air-cooled condenser. I'm like spacing on the terminology. That's feeding 3 different air handlers, small air handlers, and then ducted distribution. So we basically have 3 zones, but we can keep it really tight. The ducts don't have to go out to the perimeter of the building. The systems are small. Architecturally, it's much easier on the building.
Just one little bit. Some people don't like forced air systems, though. You know, if maybe allergies or too dry. Is there any way around that?
Right. Well, the thing that's interesting is that, you know, in a passive house, you have much greater control over the indoor air quality, as well as the humidity as part of that. So those issues kind of go away. The other thing is it's typically very low volume, and so you're not feeling it. You're not getting blasted by any stretch of the imagination. You do need to distribute it, but you don't need to put it like every 10 feet. Yeah, we'll talk a little bit more about that in a second. So this is really where, you know, a big chunk of the savings come from up front in this simplification. And one of the other projects was a house renovation in Westport, and it was actually like true Bauhaus construction, concrete building from the 1920s, and we essentially wrapped it in this foam glass insulation and stuccoed it, and architecturally did some simplification to the building. So we're from the historic townhouse, everything was interior. This was almost everything exterior to the building, and just really wrapping it. And here, literally, you can see sort of wrapping it in a parka completely. And you see the windows integrated. So the ventilation, basically what you have is an ERV or HRV, which is doing the high efficiency heat recovery. So you have ducts going, supply and exhaust ducts going through the exterior wall here. Well, they haven't been hooked up yet, they're coming out of the top. And then return and supply distribution ducts going out through a manifold through the building. The ventilation air is running continuously, 24/7. It's never shut off. It's not like a bath exhaust where you run it for 10 minutes and you kill it. It's running 24/7, but at a very low volume. One of the things with passive house is you're trying to maintain very good air quality, but you're trying not to waste energy. So like Marty mentioned, the minimum requirement is for heat recovery is 75%. So as you're continually exhausting air from the house, you're retaining at a minimum 75% of the heat. So you're keeping the warm in, the cold out, or vice versa in the summer, keeping the cold in and the warm air outside. The units, like the Zender unit and others, have heat recovery efficiency now of well above 90%, which is pretty amazing. And you can recover some moisture with the ERVs to help with humidity issues, but it may not be necessary. It gets all very complicated very fast, and there's not really a consensus. But the basic thing, like Marty was mentioning, we're supplying air continuously to the living spaces, the bedrooms, and you're exhausting continuously from the kitchen, powder rooms, bathrooms. So you have the right flow of air to have continual mixing and distribution. We also do have a solar hot water system in this house, and we have a coil, I think it's up here somewhere, a hot water coil, so if they need heat, they can actually get heat from delivered through the ventilation system throughout the house. Simplifying it yet again. There's also a split air conditioning and heating in this house, a very small unit. But this is the basic idea. And one of the things in limiting the heat loss, I would say also is one of the notions is that more ventilation is better ventilation, that you can't ever have too much fresh air. And that's true, I guess, as far as it goes. But in terms of balancing needing to conserve energy and having fresh air, what they really try to do is supply just enough air to ensure really good air quality, but not more. So once you've supplied enough fresh air, which is roughly 0.3 air changes an hour, you don't need to supply more, and so you really try not to. And in the PHPP, when you're calculating a passive house, if you're supplying too much air and you're getting those additional heat losses, even though you're recovering a lot of heat, it's a real penalty, and it encourages you not to do that. So this is just a interior shot, nice. And so these triple pane windows, like you saw the earlier slide of the girls sitting in front of the window, the triple pane windows, big pieces of glass. You have floor to ceiling glass. You don't need heating under it. You can stand in front of it in the middle of the winter and be comfortable. I mean, it's really amazing.
That's a significant investment for a large window like that, right?
Sure, but if it's on, fixed windows are a lot cheaper than operable windows. And those big ones aren't going to be operable. I mean, that window weighs literally a ton. It's you need to have a forklift or something to move around, or a good team of people to lift it up. So this was sort of the reinterpretation then, which the preservationists in Westport tried to stop the project as well. And they were actually also pleasantly surprised, I think at the end of the day, that it actually ended up getting a preservation award because while we changed it really significantly, it was felt that we really maybe carried the spirit of the old house forward and rejuvenated it going forward. So that was really exciting. And you can see the solar panels sticking up on top. So solar is part of it. Passive solar with the windows. People sometimes will confuse passive house with passive solar. And really the big difference is that passive house is focused on the whole building fabric in a truly integrated way, and passive solar is one piece of that integration. Where in passive solar, the real focus is on those solar heat gains. One thing that you do when you're designing is really calculate in the PHPP the balance of the solar heat gains and losses, not just in the wintertime, but in the summertime, that you don't want overheating. You need external shading sometimes. And really, so more glass is not necessarily better, for sure. And typical, decent-sized building, like the building we're in, certainly, or others, you can have about 30% vision glass on the facade, almost all the way around, maybe down to 25% or so on the north, but a decent amount of vision glass all the way around the building. It's not like all the glass needs to be on the south side, no glass on the north side. As you get to smaller buildings, the impact of where you're placing the glass is much greater, but as the buildings grow, you get a lot more freedom in terms of the overall energy balance. So I would just say that really the idea is to focus on the energy and the methodology of the energy, and it doesn't preclude any other aspects of sustainability. Like, it's really meant to complement things like LEED, Living Building Challenge, Cradle to Cradle. All of these things are great, but Passive House is plugged in a way to give it certain really clear qualities, but give you really a range of what's possible. Really anything's possible. And so lastly, just encourage everyone, if you haven't seen it, there's a great 20-minute documentary by a Brooklyn documentarian named Charlie Hoxie called Passive Passion, and it focuses on some New York practitioners. And we actually paid for the honor to host it on our company's website. So it's there to view, and just encourage everybody to take a look and share it. It's a really nice tool as an introduction to the standard. So that's it for me. And so I guess we're going to have a Q&A discussion.
Yeah, there's a time for a question and answer, and I guess before we start, I just want to say that I have an architect drawing up the plan for the passive house that I want to build. I guess I grew up around Detroit, spent half my life in New Orleans, went through Katrina. That's where some of the ideas I got for passive house originated. But coming to New York, the typical building design you see all over the place. It's a shop house where you have commercial on the bottom, living space up there. And in my mind, this is the only house that I want to build. And there's only one type of construction technique that I want to build. So I want to do one thing very well and sell millions of them. But essentially, I want to build a modular building that's got concrete on the outside and inside, and then have something like extruded polystyrene on the center. It's just what makes it unique is how I put the thing together. And since I'm trying to get a patent on it, I'm not going to talk about it. But essentially, what my passion is to build something that can be as cheap or cheaper than the standard technique to move the movement forward so that it's a common thing rather than the exception. So why don't we just open up for questions and
So I have a question about, you were talking about the financing.
Sure.
For these, so there's an upfront cost, and you were saying that it's paid back by the energy savings, even though you have to get more leverage to do the project.
Right.
The issue that I would see with that is that you still have to, if you're going to get a bigger mortgage, you still have to communicate this cost savings to the people you're getting the lending from.
Yeah.
And I'm wondering another avenue might be trying to get incentives, sort of centralized government incentives to build this house, but that would require some recognition of this standard, the certification that you're talking about within the legislature. Is that present, or are you going for that?
Well, we're not really pushing for that at this point. We're trying to build some basic competence out there to begin with. So if one day with the stars align and it starts to ramp up, we need people to be able to actually produce it. And so we're actually okay with the more incremental growth at the moment, but it will be great. I mean, it does need to take off in our view. So we haven't been prioritizing that push. I know some states have gone further in sort of code incentives in Massachusetts and I think in Oregon and other places to incentivize passive house type low energy buildings. I'm not aware. I don't know. Of course, Jamie wouldn't know. No, Brent, would you know?
No.
Well, we got the Brussels experience coming up, 2015, having the building code, maybe.
Yeah, I mean, Brussels is a pure example of if there is the political leadership to make it happen and they have the savvy to do it, that really anything is possible. I mean, because Brussels is a good example because they weren't Germany or Austria, which were crazy energy efficient places to begin with in a way, and super rigorous. Brussels is the worst performing city in Europe in terms of energy efficiency. They were terrible. And they went from being the worst student to being the best student is the way they like to describe it. But I think, our sense is that the financing, when you talk to people that are in the financing world that deal with decent-sized buildings and buildings that are dealing either with LEED certification or just Energy Star or energy efficiency improvements, that the money, generally the word that we hear is that the money is there and it can be gotten. The problem is not the money so much, it's just putting together the team and the package and putting it on the table.
Yeah,
so,
considering it from a push perspective versus a pull perspective. Like the Brussels thing is a mandate, whereas
right.
if you were to have incentives built into the cost structure via taxes or government or whatever,
yeah,
pull people into the process.
Yeah. I mean, the big thing that we're seeing right now out of the gate in that discussion a little bit is the tension, and I think we're going to see it in this administration between, and I think it's a false dichotomy between affordable housing and energy efficiency, and people see any added cost as taken away from more affordable housing. And how do you address that political reality? So it's really complicated. I don't know. It's like, yeah, we're just trying to figure out the thermal bridges. Yeah.
Oh, yeah, well, we have the New York State, the New York City, and U.S. government tax benefits of doing energy conscious things.
Right.
So a question about.
But they're very limited. I mean.
They're limited, yeah. But June, they're largely appliances also, for instance.
Yeah.
June 17th conference, do we go on this website to enroll? For that?
You can find it there, but go to the New York Passive House. So nypassivehouse.org.
And
Well, and you'll have a link to the event from there.
But where is it again?
It's 18th Street and 6th Avenue. Yeah.
Just to add to that financing question, I do New York State and several other states have a program called PACE, and it's kind of new. I think it's in the last 5 years. The idea is that you can pay off larger energy efficiency projects by tacking on money to your property tax assessment, so that you can sort of pay it out over time. So this is one way that a lot of larger capital projects are able to fund these types of things. And of course, as mentioned before, you could get rebates through a nice survey in New York State.
Right.
That your energy efficient cover units, the windows, I'm sure you can qualify for rebates and incentives. But for large capital projects, I would look up PACE, P-A-C-E. There's a movement of people trying, on the financing side, trying to push energy efficiency retrofits forward because it's expensive.
Right.
So check that out.
Yeah, good, great. Daniel?
Allow me to have two
Sure.
questions. First one's pretty quick. As far as the name, has there been any discussion about changing it so that people don't think of it just as houses? And because we do want it to move to
Yeah.
buildings and skyscrapers and luxury condos and all
Right.
that, right?
I think it's the first thing everybody comments on. At the end of the day, after the whatever internal discussions happen, the feeling is just sort of like that bet has been made, and it's time to fight other stuff. So that's why, hopefully, if the big buildings are out there and are in people's imagination, we could make that conceptual leap.
Right. So we'll have
But
that.
the name isn't going to change. I mean, the only thing that people may do, and some people do here, and in the UK they use the German passive house as a differentiator, and because house in German is more building than single-family detached house. So I guess a more proper translation would have been passive building, but.
Otherwise, we're going to have passive house skyscrapers. Kind of weird.
Right. Well, it's going to be, it'll be, hopefully the idea is it'll be like Kleenex and Coca-Cola. It doesn't really matter at the end of the day what crazy name it might be.
Yeah, Xerox is kind of like gone away.
Yeah, well, along with paper, right?
The other thing I was wondering about is one of the things I like about passive house is it's not prescriptive, it's performance, right? So there's only really 3 numbers you have to, but why even have 3 then? If we care about climate change, isn't it the source energy per square foot? Really
Yeah, there's arguments about that too.
Okay, so
And you could really boil it down to one number, which is the load number, which is like 10 watts per square meter. The load is the peak demand.
source energy per square area, right?
Right.
That's what you really care about.
Right.
So like, why get into saying like you can only use this much for heating and have this much air change?
Because
Let people do whatever they want, figure it out how they may.
Yeah, I think, I don't know, I could take a couple of educated guesses why that's happening, but I mean, I do think it comes out of you need a set of tools that you can really speak to the performance of the building in terms of comfort and durability and those kind of occupancy issues, which the heating and cooling and airtightness speak to. So, because you could probably, theoretically, you could probably do a pretty awful building in a way, maybe, and still have a low source energy. I don't know. And that they're really trying to lock down in those 3 metrics, which Marty showed 6, which is kind of an elaboration on 3 essential metrics: the heat demand, the primary energy, and the air tightness. I think they boiled it down to as few as possible that still guaranteed the comfort criteria, and to the extent possible. But that's my.
So if you got those primary 3, the other ones come along, I guess.
Yeah.
So.
I mean, a lot of people argue that for sure, and it's a good thing. I mean, and the Institute is actually coming out with a new set of certifications that actively incorporate on-site renewables for Passive House Plus, and I don't know what they're going to introduce it at the international conference in April. So it should be interesting, and we'll talk about it at the conference in New York.
There's more questions. Go on here. No.
Just 2. First, guys, it was great. It was a great presentation. Really enjoyable. But I'm going to have a little difficulty going home tonight, because I know my wife's going to say, well, what's really the difference between green and leads as opposed to passive? So you can help me out there a little bit?
Sure.
Okay.
I mean, what do you want us to say? Or
Yeah, I did a little bit of, because I anticipated this question. And a couple good.
I'll give you the one-liner when he's done.
No, there's a real good article by Pane in 2007. He said, "What's wrong with LEED?" And a couple of the relevant questions. He says that design is a manifestation of the forces that are driving it. The design, rather than coming up with a point system. Things that may not have any effect on the. His point was that what matters is the BTUs per square meter, CO2 per capita per square meter, so it's performance-based. Then there was another article by a guy looking at rural Africa, and somebody was saying, well, why don't you put some green features in these hamlets in rural Africa? There's things that are just irrelevant in that environment, where electricity is a luxury, so it might be more important to put mosquito netting. So this might be an extreme, but in terms of LEED and passive house is all performance-based. And I think in the LEED system, there's a push toward green thinking, green activity. There was a point that one of the authors in the article made was that you get the same number of points for putting a bike rack as some other green feature. And or you have energy efficient cars having parking space, parking cars in Africa, have cars. So depending on the space, so it's a little bit of a Western chauvinism in a sense.
So I would put my line on it would be that, I mean, LEED has been incredibly powerful in transforming the building industry in this country in particular, in thinking really in a global way about sustainability from site to planning to all the way through the building. I mean, all kinds of qualities of the building and in society, really. And passive house, so it's focused on a full range of sustainability issues, which are totally important. Like, we need to be thinking about everything. We can't be exclusive. But Passive House is thinking really just about the building and thinking really just in a performance basis, the way that Marty's talking about. And really focusing on climate change and operational energy.
The first time you guys heard the term, did you think it was synonymous with green and LEEDs?
I didn't think it was synonymous with LEED, but I thought it was what I would describe it as fulfilling the promise of green construction. That green construction has gone a long way in terms of dealing with materials, toxicity, things like that. I mean, there's still more work to be done, to be sure, in site and everything, but the one piece that's really been left on the table is the energy performance of these buildings. And so Passive house closes the gap on the energy performance issue.
Well, on the other aspect of what you do, you mentioned about the glass, that we have to import it.
Right.
No American companies can, I mean, are there patents that prevent
There are
that?
a couple of American, no, it's open. There are a couple of American companies that do now have certified windows, and you don't have to have a certified window. And depending on the climate, you could use double pane window and a pretty typical American window. But as the climate gets more difficult, you need to be more careful and have higher performance products.
It's not a historic district.
Right. Right, and there are, so there's more and more. I think the American companies will come, but it's just going to take time.
Isn't Marvin one of those too?
Well, Marvin has a passive house window, but it's not certified, and it doesn't come anywhere close to the metrics. It's a marketing thing that Marvin's doing.
One of the two that are.
Cascadia window, they're very small boutique companies. Casa Grande windows, I think, in California, and one in Vancouver.
We've got 5 minutes.
They're not going to be your cheaper way to go. It'll be a lot cheaper to get them from Europe.
More questions?
Yeah, I may have missed this. How many certified passive buildings are there on the planet?
In the planet?
Approximately.
I think we probably know more about New York.
No, I mean, there's a
Okay.
few in, so it's interesting. So there are a few in New York, literally like,
Handful, okay.
yeah, literally a handful. There are probably a couple dozen passive house projects that aren't certified that would qualify for the metrics. So the whole issue with certification is interesting along with passive house too, because ultimately what passive house is describing is the quality of performance. And you don't need the certification to be passive house, but you do need the performance. So if you can deliver the data, you're legit. But what helps with the certification and why certification is encouraged, at least in the first couple of projects that folks do, is because it's an incredible learning process. That you're working hand in hand with the certifying body, whether that's PHI directly in Germany or one of the certifiers from around the world, it really helps you not make dumb mistakes and get high quality right out of the chute. But well, just the last thing, generally, after folks do a couple of certified projects, unless they need to do it for government tax incentives or something like that, they don't certify. So consequently, of all the passive houses in the world, generally speaking, in Germany even, where they're doing it left and right, it's only about 2%, 5% that actually are certified. It's a very low percentage.
Yeah, I just wondered, in the design side of it, a lot of the structures you're talking about, basically, to me, you're in a cocoon. It has to be sealed, it has to be
Thermos.
contained. Right,
A
thermos.
thermos.
Is there any way, or is there any thinking about designing in, say, within a indoor space, someplace where you can get outside so you can still experience that whole idea of the open windows or the deck? I know you said bolting onto the outside is better than breaking the thermal integrity, but is there some of that getting into the design? Is it possible? Because it just sounds like
You can open your windows.
You can open the windows, open the doors, if you do that with this house, you
No, you can absolutely open the windows.
momentum. You got to start all over.
Well, depending on what the outside is. You saw that one slide about the opening of windows in summer.
Right.
You can. And even in certification, there's an allowance for so many going over the 68 degrees.
Yeah.
Things like that.
My only thought is like in the winter, say, if you did that, right, with a small heating system and everything, to get that house back up to temperature might take a week.
Right, well, you don't want to send it into deep freeze,
Right.
right? But the neat thing is you can walk away from the house without the heating on and it won't go into deep freeze. It may take a little bit, and so it's interesting, like school buildings and other buildings that have, week occupancy during the week and it's not occupied on the weekend, they have issues of these startup issues and how you get the temperatures back. But you can open the windows whenever you want and the doors and let the breeze come through. Obviously, if it's freezing out or boiling hot out and you have the air conditioning on, to the extent that you do it, you're wasting energy. So it's up to you. So the averages where they have the 90% reduction, they're averages, and some people are better at saving energy and some people are worse.
Let me see.
Okay.
I just wanted to ask about the air exchange. If you have a power outage,
Right.
and that's exchanging your phones.
Yep, you need to crack the
How
windows
do
down. Well, you could just let it go for a few days with the windows closed, and once it starts to feel stuffy, crack the windows.
How do you feel about Mayor Bloomberg's 2030 plan? Is it going to continue to be supported by de Blasio? Ed Mazria was here at Pratt a year ago in a lecture and said that the curves that used to go up like this, because of the major architecture firms and the major middle range architecture firms, the curve is already much more leveled out in terms of energy.
Right, it's much better. It's better because of what's been done, yeah.
How do you feel though about 2030? Is it going to survive?
I would say the short answer is yes, and I think, we'll see what ends up happening, but everybody acknowledges that 2030 is a great start, but it actually doesn't get us to where we need to be. 2030 is not the goal, and the city actually just revised and released a report called 80 by 50, which is 80% reduction in carbon emissions by 2050. And what you see is with the graph, the old 20 by 30 was a significant flattening, but the 80 by 50 goal is a whole different trajectory to get what we need to be. And I would be remiss without saying that the Urban Green Council did a wonderful report, and some of the authors in the audience here, called 90 by 50, pushing that they knew we need to hit 80 by 50, so they said, well, let's show 90 by 50 reductions, and then if we don't hit 90, let's hit 80, right?
Eventually,
Roughly speaking.
Eventually, it's going to be called Not in My Lifetime.
But I think they will.
I guess that's it.
Well, I just wanted to return for one moment to the question of government, and only because New York City, the government is about to embark on major Sandy rebuilding.
Right.
Hasn't yet begun, but it's happening any minute now. I'd love to see some of this get incorporated, because what an opportunity. They're about to be spending how much money? And why not make it, the next step?
Here's my card if anybody needs them.
If you can influence.
Appreciate all the interest and all the questions, and we'll be here if you want to ask questions. So thanks a lot.
Thank you very much.